We'll now continue our discussion of the inverse trigonometric functions. We're going to continue talking about how to evaluate these inverse trigonometric functions. Our examples this time will be a little bit more complicated than the ones we did in the last presentation. We're going to look specifically first at examples where we are dealing with an inverse trig function and also the same root function in the same problem. For example, we might have a cosine inverse and a cosine in the problem, or a tangent inverse and a tangent in the same problem, or an arcsine. Remember, that's the other notation for sine inverse. So sine inverse and sine in the same problem. Now, we have been taught in, say, an algebra class that a function and the inverse has sort of an opposite relationship between them, in that whatever the original function does, the inverse function will undo. So we have to be careful with these type functions, because often students will look at these and will say that since we have an inverse function and we have the original function, that they sort of cancel each other out and leave us the answer. So like in part A, a student might look at this and say we have an arcsine and a sine. Those two functions undo each other, leaving us an answer of 3 pi over 4. Now, in some cases that is true, but in other cases that theory or that process doesn't work. So let's look at this and see in what sort of situation that actually works, and when it doesn't, let's find the answer that we have. So I'm going to begin with part A. And what I'm going to do here is actually work out part A. So I'm going to start inside the parenthesis. And I'm going to work on determining what is sine 3 pi over 4. So if I want to determine sine 3 pi over 4, I might use the idea of a reference angle. So again, I'm going to work right here on this part, and this part doesn't have anything to do with an inverse. So I'm going to consider where 3 pi over 4 is when I graph it. So remember that pi over 4 would be the diagonal here. 2 pi over 4 would be straight up. And 3 pi over 4 would be here. My reference angle would lie between the terminal side and the positive x-axis. And so that reference angle would be another pi over 4, taking me down there to that pi line. Remember that this would be 4 pi over 4, the straight across line. So the difference between the angle of 3 pi over 4 and the straight line of 4 pi over 4 would be pi over 4. So sine of pi over 4 should have the same value as sine 3 pi over 4. And remember that sine pi over 4, right, so here's pi over 4, the sine value is square root of 2 over 2. Okay, and remember that we also have to consider when we're working with the reference angles, the positive or the negative sign. So remember that on a sine function, it's positive in both the first and the second quadrants, and negative in the third and the fourth. So both of these answers will be the square root of 2 over 2, and they will both be positive because our angle lies in the second quadrant. Okay, so I know now that sine 3 pi over 4 is square root of 2 over 2. And then I'm going to drop this arcsine down, so I'm going to now do the inverse portion of the problem. So I need an angle, and remember that if you're doing an arcsine, you're limited to quadrants 1 or 4. Because our value here is positive, we want to be in quadrant 1. So I need a quadrant 1 angle that has a sine value of square root of 2 over 2. So here's my sines. Here's square root 2 over 2. The angle going with it is pi over 4. And so the answer to the problem then would be pi over 4. So it would not be 3 pi over 4 as we first thought. So let's consider how we would know this, okay? So it lies in the quadrant idea to determine whether it's going to equal the same value or not. We recognize that sine 3 pi over 4 is a second quadrant angle. Furthermore, we know that when we evaluate sine in the second quadrant, we're going to get a positive answer out. When we take the arc sine of something that's positive, we know we're limited to quadrant 1 or 4, so our answer is going to lie in quadrant 1. So the original angle was in quadrant 2, and we know that our answer is going to be in quadrant 1, and so there's no way for those two to be the same answer. Okay, so let's move on. I'm going to skip part B for just a second, and let's look at part C, and we'll come back to part B. Okay, so I'm going to do the same thing. I'm going to start here with the inside part of this. It doesn't have anything to do with an inverse yet, and I'm going to evaluate that. So I am going to use a reference angle. So I'm going to first plot 7 pi over 6. So we're going to count this thing out. This is pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. And one more would make 7 pi over 6. All right, so remember that your reference angle is going to lie in here. And the difference between 7 pi over 6 and 6 pi over 6 is 1 pi over 6. So I need to consider what tangent pi over 6 is going to be. Well, let's go back to our chart. Tangent at pi over 6, here's pi over 6, here's the tangent. That's going to be 1 over the square root of 3, which I will quickly rationalize to see that that's equal to square root of 3 over 3. So this is equal to root 3 over 3. Now we have to consider the positive and the negative between the original angle and the pi over 6 angle. So we know for tangent is positive in the first and the third and negative in the second and the fourth. So pi over 6 is in the first, 7 pi over 6 is in the third, and so they're both positive. So now we know that tangent of 7 pi over 6 is going to equal root 3 over 3, and that will be positive. And now we're going to take the inverse of that angle. Okay, so again, if it's positive, we know that our tangent inverse should pull an angle out of quadrant 1. So let's go back to our chart. I need a place where tangent is equal to square root of 3 over 3, which is here. And our angle will be pi over 6. And so the answer to this will be pi over 6. And so again, not the same value as what we started with. And the reason why is 7 pi over 6 is quadrant 3, which is positive. And when we take the inverse tangent of an angle that is in quadrant 3 that has a positive value, it's going to flip it back to quadrant 1. So note in example A and C, we had a difference in quadrants, which caused the answer to be different than what we started with. However, in part B, you can see that our quadrants will be the same. All right, so let's look at this. So this inverse cosine of something that's negative, remember that if it's negative, it should produce an angle in quadrant 2. When you take the cosine of a quadrant 2 angle, Now, I don't even necessarily have to know what that angle is, but if I take the cosine of an angle in quadrant 2, it's going to be something that's negative. And since that's the case, then we are safe to assume that the answer to this problem is not going to change. And so that the answer to this will still be negative 0.2. All right, so keep in mind that if your quadrants are different, like what we had here and here, it's going to produce a different answer. But if your quadrants line up, like what we have here, we have an inverse cosine, which is going to produce an angle in the second quadrant. We take the cosine of a second quadrant angle, we're expecting to have a negative answer. If those things match up, then we can go ahead and assume that our value will be the same.